Okay, so this video is going to be a pretty long video, and it's going to be about breaking down code and setting up a simple SQLite app. So here we go. Let's talk about installing SQLite. This is our app in Xcode. Um, and as you can see, we have a simple project where well, I'll explain the functionality in depth, a little more in depth later, but in um in a nutshell, it's going to allow us to enter a username and phone number and retrieve the username and phone number for particular users. That's it. So, and we're using SQLite to save the data or persist the data. So let's talk about this. In order to set up, is actually relatively easy. You're going to highlight your project right here, and then you when you get that open, you will see, you know, in your main panel, general signing and capabilities, a resource tab, info, build settings, build phases, build rules, right? And you're gonna go to your build phases, okay? And then um you will add this right here. And let me show you more in the app. Okay, so again, I'm in my build phases tab. I go down to compile sources or link libraries. That's it. Link binary with libraries. I click that plus button, right? And then I search LIBQ. Okay, is that it? Let me cancel. It's LIBSQ. So let me go back here, right? And of course, there isn't one already. LIBSQ, and that's it right there. Three. And then I select that, and then I add. But I actually already have it, so I don't have to add it. So once I add that, the library is there in our um in our project. Then I go to our database manager and I import SQLite 3. That gives me access to add and manipulate SQLite so that it works for us. And this is really as simple as that. So let's go back to our presentation. Okay, so now we have that. Let's move on to the next. So we're understanding file manager in the context of this app. So file manager object is very important. So in this app, file manager is used to dynamically find, manage, and delete SQL database file. It ensures the app interacts with the correct file path based on the device it is running on. So in a nutshell, when you have your database, your SQL database, and a lot of things, uh, basically, depending on the device that you're on, that path changes. Okay. If it's Apple Watch, if you're running in your simulator, if you're running it in your iOS app, the path changes. File Manager object is one of the tools that are used to find the path and use the correct path um of your SQL database. So, what is File Manager? File Manager is a built-in Swift class that provides methods to interact with the file system. It allows apps to locate directories, documents, and caches. Okay, you can create, read, and delete files, check if a file exists, manage file paths dynamically. Now, since iOS and macOS restrict direct access to the file system, Apps must use the file manager to access their sandbox directories. Okay. Mm, And that's for your own benefit, for security purposes. Okay, so why use File Manager here? It ensures the database is saved in the correct location for any device. Works across iOS, iPad, Mac OS, and the simulator. Prevents hard coding file paths, which would break in different devices. What happens if File Manager is not used? The app crashes when trying to access a hard coded file path that doesn't exist. Files on different devices because Mac OS and iOS and iPads have different file structures. Database cannot be deleted properly, leading to storage issues. With File Manager, the app always finds and manages its database correctly. So, SQL query examples in iOS development. Regardless of the method, knowing SQL basics helps in iOS development. So that means creating a table, inserting a table, retrieving data, updating data, and deleting data. Now, I don't have a lot of the code here. We're going to get to that in when we go through the code in our project. Okay, but before we do that, I want to break down an actual query used for creating the users table. So basically, in our app, we're going to have an app and it stores information about users, the first name and their phone number. So we created a users table, right? So I want to explain this syntax and the logic behind it. Okay, so this is it right here. This is the string. And we make all of this, you pass a string that says what we want. Create tables if create table if not exists. Okay. So if the table doesn't already exist, create table called users. Okay. And the ID, this is how you declare ID integer primary key auto increment. This means that whenever whenever you create a name and a phone number in your app, the ID will be created automatically and it will auto increment. So if the last number was 3, the next one will be 4. And the number after the next record after that, the ID will be 5, so on and so on. Okay. And this right here says with these properties, name and phone number are allowed to be, right? So name can't be null, phone can't be null. Excuse me, phone can't be null. That means not null means something has to be there. There has to be a value. And on top of that, for phone, the number must be unique. You can't have a duplicate number in there. It won't allow it. That's what that is. So this query is stored as a multi-line string. It defines a table called users with 3 columns. And I've already explained these columns or properties. Okay. Now let's talk about each part. Create table if not exists, users, right? So basically we're trying to see if this table doesn't exist, we're going to create it. Then we create the table and then basically this asks, people ask why use if not exists. Why is that important? And if this is just create table users, running a query twice will cause an error, right? So basically, it checks that if we're running the same query, meaning create a table, we'd have 2 tables with the same name. That would have to cause an error. So this prevents that by checking if the table already exists. Okay. Each column is defined with a name, data type, and constraint. Okay, I've already explained that. Okay, so let's talk about the SQLite creation, table creation code. Okay. Okay. So let's talk about, I'm gonna go through all of these. This line, if SQL3 prepare, this line right here takes our opaque type. That's what this is. And this is a pointer to the actual database. Creates a table, and this is our query, a string. This says that we should I can't remember. Gosh. I think it reads the entire query. Um, so let's actually look at the code and we'll go through it line by line in the app. So here's what we're gonna do. We have our app right here, and in our app, we have our database manager. This is the functionality that we use to reach out and manipulate our database, add records, delete records. Okay. We have our, excuse me, we have our content view right here. And our content view is what we're going to use to um, display our view. We have a text, a name text field and a phone number text field. We have a button under it to save the user. And then we have a list beneath that that will display the name, phone, and the ID of the user ID. Okay. And I'm going to demonstrate right here how this looks, right? So Scarface, MC8. So let's create another one. I'm just putting in different recording artists or actors. Corey Haim. And the save user. And Corey Haim is the next one. Okay. And as you can see down here, I have this where it's saving you loaded users, three users in list. These are their IDs. And so let's go back to our database manager and let's look at this code. And by the way, this code is I have it as an attachment. You can take this, post this in your um post this in your project and run it. Simple as that. Oh, and by the way, yeah. So all this is normal. There's nothing new about that. So let's go back here. So you have a class database manager, and you have this right here. It is shared. It's a statically shared database manager, which makes us a singleton. Why do we have it as a singleton? Because as a singleton, you can only create one instance of it, and basically only one connection, database connection can be made, saving on resources. So if you want to access the database manager, you have to use that same connection. Okay, no, not a whole bunch of connections can be made. All right. Um, opaque pointer to our DB. An opaque pointer in a nutshell is, again, this is a pointer to our database, but it's a reference. It's not a copy of it. It's a reference, And it's opaque because, again, Apple doesn't want you going and looking at the inner workings of everything. That's why it's opaque. This isn't like other data types that that you can either create custom or that are already there. So yeah. So this you can only add or delete or remove or set it to nil, right? But you can't modify the inner workings of this type. You can't see the inner workings of this type. Okay. So let's see, jump definition. Right. Unsafe pointer, right? So yeah, so you can't go and explore the inner workings. You can set this to open database, DB, and then there's a function called create table. This is done as soon as it's initialized. Let's go here. Create table. Create table has our statement, right? This is our string, our create database string, right? Create table if not exists. So basically you're checking if it exists because you don't want to create a table that's already there. Okay. Doesn't exist, users, right? And you have these curly brackets and you have an ID, which is an integer. It's our primary key in our database because all relational databases have a primary key. Okay. Um, and that's just with relational databases. And it has an auto increment. So basically, for every record, this increments, right? So the ID, you start off with your first record is 1. You put in another record, the ID is 2 automatically. Next record, the ID is 3, and so on. Okay. Name, you enter that, can't be null. Phone, you enter that, can't be null. And it must also be unique in your database. That's what that's for. Okay. Our statement, opaque. Okay. Let me go back. All right. So now, right here, see this right here. Okay. So this is this create table query. This passes um this passes a compiled version of the query. Um, and so basically, this line tests that if this statement is okay, everything checks out, right? Then it runs this statement, and the table is created. Okay. Otherwise, um, we throw the error message with the problem went wrong creating the table. Or we have a problem with the creation statement. And then we finalize it. Okay. So now let's go back up here. Um, get database path. Um, open database, create table. So we already did create table. Now we have these functions, get database path. Again, we talked about the file manager. The file manager basically is going to be used to get the path of our database. This is just how you build the path to the database so you can always reference. Okay. Um, Now we're going to open the database, right? And of course, we have to get the path in order to open it. Okay. We've already looked at create table. Okay. We need a function that tests if user exists. So basically we're checking if user exists and it has if this phone number. Okay. Again, we have an opaque pointer. And this query is used to build the statement. Okay. And later on, I'll go into this, I'll go more into query syntax. But for now, for now, I don't want to go too much into it because we're going off on too many different tangents, too many. What I'm gonna have I'm gonna explain query syntax in the next video. Right here we insert users, right? A name and phone number. We trim it. This is how you remove the white space from the fields. Okay. And of course, this is when we have an attempted insert and we're printing this to the console. Okay. So I have a lot of these little print to the console things to help debug if you ever have any problems. You can find out what is going wrong. Okay. User exists, right? Prevents duplicate phone numbers. This creates an SQL query. Inserts users into phone values. Okay, question mark, question mark. Of course, this is name and number. I'll explain that later. Um, Number. Now you have fetch users. Fetch users we're going to use to pre-populate our list on in the view, right? The function that's going to call. And you can go and select ID from users order by ID descending. That's what you'll see in the list. And these print to the console when there are errors doing that. Okay. And delete database. That's the button all at the bottom that allows you to completely delete all of the contents of the database and the database itself. Okay, so there we have it. Um, and so let's run this. And there we are, Corey Haim, Scarface, MC8. Okay. Again, I'm just thinking of just names. That's it. And there we go. We have 4 users. Okay. Then when I want to delete it, I can delete all the users. And now I have nothing in here. And now I can go back and add. Okay. All right. So there we go. And I'm going to add the code. As a resource, I'm going to add the database manager, the content view, and I'm going to add the @main file. Remember, you take your project's name and put it here, okay? App, okay, right in front of this app, right behind the app, I mean, or in front of the app, okay? Your project's name goes here, okay? Just like here, SQLite example, SQLite example, app, okay? All right, on to the next.